Hi, my name is Igor Zavalyshyn. I will present the results of our analysis of modern smart home systems and all of the privacy-enhancing technologies for those proposed in the last decade. We specifically concentrate on systems that rely on a local smart hub device in their design and make use of its capabilities. I will hopefully convince you that there is little privacy in smart home systems nowadays, but there are ways to change that for the better. This is a joint work with my colleagues Axel, Legay, Annanda, Rath, and Etienne, Riviere. We are from UCLouvain and Sirris in Belgium. Just to give you some context, let me first define what we are dealing with. Nowadays, there are millions of smart home devices available on the market. They allow us to have better control of our lives and automate daily routines. At the same time, these very same devices can also be used to spy on us. They can control the environment we live in, they can watch us and listen to every word we say. As a consequence, many smart home owners, both existing and potential ones, raise privacy concerns regarding sensitive data collection and processing without their awareness or consent. To understand this problem, let's look into how these devices operate as part of a smart home system. We have a sensor device on the left that operates within a smart home and collects sensor data. Then we have a smart hub in the middle that forwards sensor data to the cloud server on the right. There, the data is being stored and processed by various automation rules and third-party services. The cloud server can also respond back by sending commands to local actuators that are again forwarded by the hub device. But between the hub and the cloud server, we have this so-called data control border that define the amount of control users have over the sensor data collected by the devices they own. While the data remains within a home environment, the users can still control it, even if it means simply disconnecting the device from power or network connection. But once the data is in the cloud, the users lose all the control and have no way to verify how that data is being used, who it is being shared with, and why it is being collected in the first place. So a smart hub represents a single point of control for users' privacy, and it can be used as a foundation for building systems that implement, among others, traffic obfuscation to protect, for instance, the device and user activity from internet service providers, data minimization to reduce the volume of sensitive data being sent to the cloud, access control both for app or user activities, local computing nodes to offload some privacy sensitive tasks, and a lot more. We wanted to understand how these hubs are currently being used to protect the user's privacy, both in existing systems and those that were proposed by the research community. To answer this question, we first defined an analytical framework that helped us to compare systems that often had different design and threat models, implemented different privacy-enhancing technologies, or even considered different operational modes. We then selected 10 most popular smart home systems among commercial and open source ones and compared those side by side. Finally, we collected a dataset of 137 papers on smart home security and privacy published at top conferences, workshops, and journals for the last decade, and used the same framework for the comparison. And of course, our selection includes a generous amount of PETS papers. So let's start with existing smart home systems. Here is a table showcasing the results of our analysis. The systems were compared based on their system and threat models, third-party application support, access control modes, and stakeholders share. After our analysis, several things became clear. First, commercial smart home systems are still predominantly cloud-based and use cloud servers to collect, process, and store large volumes of sensitive sensor data. Open source systems, on the other hand, target local execution environment, do not depend on cloud resources, and as a consequence, provide better privacy control to their users. We also see a gradual shift towards hub-centric design among a few commercial systems, namely Apple HomeKit and Philips Hue, that use hub devices for local-first data processing, with cloud servers being used for backup or remote access. However, such an initiative is still very rare and it's vendor-specific. Secondly, we notice an alarming trend among commercial systems in which the same entity acts as both device, app, and platform provider and controls the full cycle of data collection and processing. This way, one single company gains an unprecedented access to both device and user activities and can aggregate a large volume of sensitive data that would normally be impossible in a multi-vendor setting. Among open source systems, this is not the case. Only the core platform is offered. The users are free to choose the devices and apps of their choice. Finally, we see that commercial systems rarely recognize the threat of platform provider and concentrate instead on app or device provider threats. They offer no ways for users to verify the platform before using it, nor to specify their preferences regarding sensor data collection and processing. Open source systems generally have a large community of developers that collectively do code reviews and security checks, aiming to minimize the privacy risk for their users. Expert users can also freely customize the system according to their preferences and needs. Now let's look into the state of the art. In our paper, we provide a taxonomy of various privacy-enhancing technologies proposed for the smart home systems over the last decade. Again, we group them based on system and threat models, the type of PETS they implement, and where those are applied. A significant number of research proposals concentrated on protecting vulnerable and often unpatched device software components and communication protocols from external attackers. However, proprietary software and protocols of modern smart home systems make it a challenging task and often hinder the development and application of privacy-enhancing technologies. Due to this reason, smart hubs are often the only place where PETS can be applied. Some of those can be very effective, especially those that operate on network or application levels. We see a rise of proposals for novel privacy-aware system designs and programming models, but their threat models rarely consider the platform provider as a threat, and even less so for a device provider. So here let's make a stop for key takeaways from our analysis. A large fraction of smart home systems are still cloud-based, which limits the user controls over sensor data. However, a local-first model has gained traction over the last few years and is gradually adopted by the industry leaders. We see a similar trend among research proposals. Early works on smart home systems strongly advocated for a local hub-centric design, but later switched to hybrid and increasingly cloud-centric architectures, following the design of commercial systems. Today, however, we see a backward trend, with computation and storage functionality moving back to the edge, where fine-grained data flow control is possible. Overall, the smart home market is still very fragmented and lacks common open standards for device connectivity, application development, and data transfer. Such standards would not only allow the users to easily migrate from one platform to another, but would also make it possible to inspect and customize a given system according to user privacy preferences and needs. Finally, the threats associated with device and platform providers are rarely addressed in existing systems, although technologies exist for secure and verifiable even data processing and storage in untrusted environments, like SGX or Trust Zone. Our analysis results show that there is still a lot to be done to improve the privacy properties of smart home systems, and we have tools and technologies to do just that. What we are missing, though, is a common vision of what privacy-friendly smart home systems should look like. we want to take this opportunity to suggest a few ideas that may help to make this vision a reality. We present our Smart Home Manifesto. We would like to make a case for a privacy-friendly smart home operating system that will bootstrap the development of novel, highly flexible, and truly distributed smart home services. We urgently need to rethink the ways we design and build smart home systems and offer a unified and, most importantly, vendor-independent operating system for those. The systems that would allow easy development, deployment, and consumption of various smart home services, and would have a built-in support for privacy-enhancing technologies that can be easily activated when using a given service. Thank you.